In this section, we'll explore physical interfaces and cabling types, the foundation of network connectivity. We'll look at single-mode fiber for long-distance communication, multimode fiber for shorter high-speed links, and copper cabling for cost-effective LAN access. We'll also compare Ethernet shared media and point-to-point connections to understand how physical designs influence performance. Mastering these concepts is essential because choosing the right medium directly impacts bandwidth, reliability, and network efficiency. Single-mode fiber, or SMF, is an optical fiber with a very narrow core of about 9 microns. Its purpose is to carry light signals across very long distances with minimal loss, making it ideal for wide area and backbone networks. It uses laser light as the transmission source and supports very high bandwidth. Because only one light path travels down the fiber, it avoids modal dispersion, resulting in cleaner signals. Typical wavelengths are 1310 or 1550 nanometers, and distances can extend for tens of kilometers. However, transceivers for SMF are more expensive, and installation requires precision. In operation, single-mode fiber enables long-haul communication, such as telecom backbones, inter-building connections on campuses, and links between data centers. Compared to multimode or copper, it provides higher performance and longer reach, though at a higher cost. Multimode fiber, or MMF, is an optical fiber with a much larger core, typically 50 or 62.5 microns. Its purpose is to carry multiple light paths, or modes, making it suitable for short to medium distances at lower cost compared to single-mode fiber. It uses LEDs or low-cost lasers like VCSELs as light sources. Because multiple light modes travel through the fiber, it is more prone to modal dispersion, which limits distance. Typical ranges are up to about 550 meters for gigabit Ethernet, and less as speeds increase. Multimode fiber operates at wavelengths of 850 or 1300 nanometers, and is generally cheaper than single-mode fiber, both in equipment and installation. In practice, multimode fiber carries multiple light signals simultaneously, providing reliable and affordable connectivity for shorter links. It's widely used in local area networks, inside buildings, and in data centers, especially for backbone links that don't require very long distances. Copper cabling transmits data using electrical signals over twisted pair or coaxial cables. Its purpose is to deliver cost-effective and flexible connectivity for local area networks and access networks. Copper cabling includes unshielded twisted pair, shielded twisted pair, and coaxial designs. Standards like Cat5e, Cat6, and Cat6a define bandwidth and performance. The maximum length for Ethernet over twisted pair is 100 meters. Copper is more susceptible to electromagnetic interference than fiber, but it is inexpensive, easy to install, and supports power over Ethernet for end devices. Copper is widely used to connect end devices, like computers, phones, and printers within LANs. It is the most common cabling inside buildings, used in patch panels and wall drops. While limited for long-distance backbones, copper excels in affordability, ease of deployment, and PoE functionality, making it the default choice for access networks. Single mode supports the longest distances, up to hundreds of kilometers, but comes with higher costs due to laser optics. Multimode is more affordable and works well for shorter runs within LANs and data centers. Copper is the lowest cost and limited to 100 meters, but it's widely used for in-device access and supports power over Ethernet. Each medium balances distance, cost, and use cases differently, making the right choice critical for network design. The standard SFP supports 1 gigabit, while SFP Plus increases that to 10 gigabits. SFP28 handles 25 gigabits, and QSFP modules scale higher, with 40 and 100 gigabit options. The QSFP-DD can push up to 400 gigabits. All of these transceivers can operate over copper or fiber optics, giving flexibility depending on distance and design. Choosing the right SFP depends on the bandwidth needed and whether the link is short-range copper or long-haul fiber. Ethernet connections can be based on shared media or point-to-point links. Shared media allows multiple devices to use the same communication channel, while point-to-point provides a direct link between two devices. The purpose is to highlight how connection types influence network performance. In shared media, devices contend for access, collisions occur, and half-duplex is typical. This was common with hubs and coaxial cables. Point-to-point connections, on the other hand, use dedicated bandwidth between two devices, enable full duplex operation, and eliminate collisions. Switch-based Ethernet is now the standard, making point-to-point the norm in modern networks. Shared media was used in early Ethernet LANs but is largely obsolete today. Point-to-point dominates in current networks, connecting switches to hosts and other switches, ensuring efficient, reliable, and scalable communication. It is the foundation of enterprise and data center connectivity. We've now covered single-mode and multi-mode fiber, copper cabling, and Ethernet connections. Each option has different features, characteristics, and best-fit scenarios. Single-mode for long-haul backbones, multi-mode for shorter, high-speed links, copper for affordable LAN access, and point-to-point links for modern Ethernet efficiency. Before moving forward, review the slides and take the quiz on the website to reinforce what you've learned. Once completed, you'll be ready to move on to the next section, where we examine interface and cable issues like collisions, errors, and mismatches.